Hi, I'm Jason with Tormach. We're wrapping up our quadcopter mold project, and I ran into a little bit of a problem, so I thought we'd do a quick video showing how we handled that issue and how we worked through it. So what we need to accomplish is I just need to face off this surface so we have a nice clean flat surface free of burrs when we're making our carbon mold for this. So I need to be able to hold this part down without putting a clamp on the top. On our PCNC 440 we have 10 inches of travel and I have a 10-inch part. What I was going to do is cut a small slot in the side of the part to put my toe clamp in and to hold this thing down on the table, since I don't have a fancy toe clamp or a wedge style clamp to just push on the side of it. I'm just trying to get this project done with the tools that I have here. And you can see we don't really have any room for a tool. Once we put the tool holder in the spindle, we have just enough space to fit the tool holder over the part. So what I'm going to do is take the nose off the tool holder to give myself a little bit of clearance and some space for the cutting tool. So to shorten up our tool holder, we came over to our 15L lathe. We chucked the tool holder in the 3-jaw and we're just going to do a quick facing and chamfer pass to take the nose off. If you don't have a manual lathe or a CNC lathe at home, you could also clamp a lathe tool in the vise on your mill and use the mill as a little bit of a vertical lathe to take the nose off. All right, so to face off the holder, we're just going to create a quick facing routine. So come in here, we have tool number 1. We're going to start. Our end position will be 0. Our initial diameter is 1.25 inches. Our final, we can go down, it's a 3/8 inch tool holder, so we'll go down to 0.3. And I put my numbers backwards there. Our Z start position is 0, and our end position is going to be minus 420 thousandths. This will machine off the whole chamfer on that tool holder. So tool clearance, we'll leave at 100, roughing depth of cut. We have an 80-degree diamond with a 15th thou corner radius, so we'll leave that at 15th thou. And we'll take a finish pass at 5 thou. We have speeds and feeds quick. We got G54. These tool holders are an alloy hardened steel, so we're going to run this pretty slow. We'll run 200 surface footage for roughing and finishing with a maximum of 2,000. And we'll stick with the 7th thou for roughing and a 5 thou for a finishing pass. So we'll go ahead and run this program here. Just overwrite the facing routine that I have. You can see it just generates a quick little program for us. I have the part loaded up in the machine and all the zeros are set already, so we'll just go ahead and get this thing running. We've got our part faced off, so we'll write a quick chamfer routine to finish this thing up. So our X diameter is 1.25 inches. We'll just do a 45-degree chamfer angle. We'll do 50 thou depth of cut, 5 thou finish, 100 thou tool clearance. Our Z start position will be at minus 0.42, and our Z end position, we'll just make it like a 30 thou. So we go minus 450. So you see we got a little simple chamfer routine here, and we'll go ahead and just chamfer this part so we don't have any sharp edges on it. Got our tool holder all trimmed up. We'll go ahead and load a tool up in here, get it into the machine, and get our slots cut. You can see we've got a 2-flute end mill loaded up in there. We did find a stub flute end mill, so we are clamping on the shank of the tool itself with a very small amount of flute sticking out. So what I did now is I just kind of eyeballed it up. It's a clamping slot, so I don't overly care where it ends up. So I just kind of eyed up my zeros. You see we just got a quick, simple little slot we're going to run. We're just going to ramp into it. Go about a 1/4 inch deep just to give the clamp something to sit in. So we'll go ahead and start this up. As you can tell, I have very little clearance, so my clearance plane on this part is about 10/1000ths of an inch. So we're really using all the travel that we have to be able to accomplish this. So we'll go ahead and start running this. As I do in every scenario, I always like to run my feed and my max velocity down at 0 when I start a program so that I can walk into it. In a scenario like this, that's helpful since we really don't have any clearance to work with. So we need to really be on top of it when we're going to run it. So I'll go ahead and hit start here. The machine's not going to move, which is awesome in this case. We're going to go ahead and just real slowly start creeping over our max velocity. Anytime you do a project that has this little bit of clearance, it always gets you nervous, which is still fun. So you can see we've got 5,000ths moved down. I'll leave my max velocity up a little bit, and I'll just go ahead and let it cut. The other fun part of this is stainless steel. So if I go too slow with it, I'm going to create my own problem. So I need to trust it enough to not run it slow enough where I ruin my cutter. You can hear we're starting to engage the material. It sounds pretty nice. And on this part I did about, I think I did 200 surface footage at a 2,000ths per revolution, or 2,000 chip load, which puts us about 2,500 RPM and 10 inches a minute. And I did a 10 thou depth of cut, so what PathPilot's doing for us is it's just ramping in 10,000ths per pass. So it's just a nice controlled slow cut for us to get this groove in here. And it's cutting pretty well, so we'll just go ahead and let it finish up. It's about 75,000ths deep now, so we'll just let the machine keep running, and when it's finished up, we'll go ahead and flip this thing over and finish the other side. So the cut's finished up, so we'll go ahead and check it out and see how it looks. Jog this out of the way. Looks pretty good. Grab the clamp here to see how, make sure that we have enough clearance and everything for it, and that'll go in there and work just fine for us. So at this point we can go ahead and flip this block over, machine the slot on the other side, and then we'll be able to clamp it down to the bed of the machine without having any clamps on top. So we've got the slots wrapped up, cut on both sides. We've got it bolted back down to the table. We've got our Superfly cutter installed, so now we can go ahead and face off the back side of this block and finish up this project. Well, thanks for watching. We hope you enjoyed it. Check out our other videos here, and please subscribe to our YouTube channel here.